Okay, so let's take a look at an example of the inverse for two independent groups. So again, as usual, if you haven't worked on this example by yourself, you could pause the video here for a moment and read the question, think about it for a while before you continue to watch. So this example is about a company who was concerned about the length of the time a particular vitamin they produce retained its potency. So they measure the potency of newly produced vitamin and the stored vitamin, which has been stored for a year. And we can see from this context of the question, even though they have the same sample size for the two groups, they are independent samples. They are not the same unit which is being measured by twice. That's the paired sample, right? So this is the independent sample. So we are going to use the information for the first two lines. And you are asked to conduct the hypothesis test and calculate the confidence interval. So first, the data is independent since we have two separate samples. So we use values for the separate groups, not the differences. For the hypothesis test and confidence interval that we are going to do. So for the hypothesis test, the first step, establish the null hypothesis and alternative hypothesis, right? The question is we are trying to see whether the vitamin stored for a year retained its potency as the newly produced vitamin. So again, the null hypothesis is always going to be something with the equal sign. And the alternative hypothesis will be mu1 minus mu2 greater than 0. I'm using this greater than 0 here because I would assume that the new vitamin will have better potency than the stored vitamin. That's why I use greater than 0 here. You could also use not equal to 0 if you want, because in this question it's not that clear. Some of you may argue, but in your exam, I will make sure that there is no confusion about whether you should use a one-sided test, a two-sided test. So here is the first step, where mu1 minus mu2 represents the difference in population mean potency, that is the new minus the stored, for vitamin for the vitamin produced by this company. So this is the first step. The second step is to check on the conditions. So we are told that those are random samples. Both samples are random sample, and we assume the populations are normal. And it's reasonable to believe that those two are independent as well, right? So our conditions are met. The next step is to calculate the test statistic. So we are going to plug in the numbers into this formula here. So this is the formula for our test statistic. So we plug our number in. That is y bar minus y2 minus our mu naught 0 divided by s1 squared over n1 plus s2 squared over n2. So this is 4.27 if you calculate it. And this one, third step, find the null distribution, calculate the p-value, and make decision about your hypothesis. This will follow a t-distribution with an approximate degrees of freedom equals to n1 plus n2 minus 2, which is 18. So we are going to find now a t-distribution with degrees of freedom equals to 18, and this is the test statistic we have calculated. We try to find the value here. So p-value is 0.00023. If you are using the StatCrunch, we are having a greater than 0 alternative hypothesis, so we are trying to find the area under the curve to the right of this test statistic. This one is less than our fixed alpha, which is given in the question. That's 5%. 5% significance level here. So p-value less than alpha, we reject H now. Then we are going to state the conclusion. There is evidence that the potency of the vitamin is lower after being stored for a year. Okay, so I will end this video here. It's about the hypothesis test of the two independent populations. In the next video, we will continue to see how we could calculate the 90% confidence interval for it.